here's another example. In this question, we're asked to find the limit of arc cosine of x squared plus 1/2 x over x as x approaches 0. Okay. The first thing I want to point out about this function that we have here is that it's a composition of two functions. So see if you can see it that way as a composition. So in other words, we have that y is equal to f of g of x, okay, and the outside function is arc cosine of x, and my inside function is x squared plus 1/2 x over x. So this is what we call a composition of two functions. So that's a very important thing to notice because in section 2.5 of our text, we are given some theorems that give us an idea about how to calculate such limits, and these involve continuity. Okay, so I'm going to remind you of one theorem that might help us with this example. Okay, so here's theorem 8 from section 2.5. And what it says is that basically the limit of this composition, okay, so this is sort of what we have here, is equal to f of the limit of the inside function, okay, and these two things are equal. So in other words, we can switch the order of the limit and the outside function, okay, and sort of pass that limit through f. When can we do that? So the conditions are that, that the inside limit has to exist, okay, so this has to be equal to some value b, and the outside function has to be continuous at that value b. So if we go back to our original example, this is saying for us that the limit as x approaches 0 of arc cosine of my rational function is equal to arc cosine of the limit as x approaches 0 okay, as long as these are equal if the limit as x approaches 0 of x squared plus 1/2 x over x exists. That's the first condition, and we need that arc cosine of x is continuous. Okay, so basically, these are the two things that we're going to have to check if we want to be able to say that this is equal to this. So let's start that process. Does this limit down here exist? Well, let's try to calculate the limit. So the limit, if I plug in 0, I actually unfortunately get an indeterminate form, 0 over 0. But I notice that I can factor an x out of the numerator. So I have x plus 1/2 over x. And then I notice that I can cancel these values, and that won't change that might change my function, but that's not going to change the limit. And I end up with this limit. Using the limit laws, I have 0 plus 1/2. So this limit exists, and it's equal to 1/2. It's a finite number. It exists. So this would be like the b value in that theorem. B is equal to 1/2. So the second question I have is, so the limit here exists. Is the arc cosine function continuous at, and let's put that value there, at b equal 1/2. So if you don't remember exactly what the arc cosine function looks like, I'm going to just pull up a graph really quickly. Okay, and you can see here it is. And you can see that when b is equal to 1/2, my arc cosine function is indeed, we do have continuity there, okay? So this is true. So let's go back to the original question. So both of the conditions are satisfied. The inside limit exists, and the outside function is indeed continuous at that limit. So the theorem tells us then that this is equal to arc cosine of the limit, which was 1/2, and arc cosine of 1/2 is pi over 3. And that would be our final answer.